Hi guys, and here we are looking at the Trigo package, Trigonometry. And so there are two types of questions, level 1 and level 2. And so we just start with the level 1 questions. This is question 1 from level 1. And immediately when we see it, we see, okay, ABC is a straight line. And we see that EAB equals to EDA, which is 90 degrees. We can see the square means 90 degrees. And AE is 5 cm, alright, and EB is 13 cm. Immediately when I see this, I feel like I can think that DB is 13. I must read EB, then I know it's EB. So to prevent myself from getting confused, I'm just gonna do this myself and say this is 13 cm. So it's clear to me. So I don't accidentally think that it's DB instead of EB. And right now they ask me for cosine, tangent, and length. So before we jump into it, I'm just going to do a quick recap, and I'm going to do it here at the top on what are the various trigonometric functions. So we have sine, and then we have cosine, and then we have tangent. Right? And for sine, basically, we always look at a right angle triangle first. And we know that the longest side, this is the hypotenuse. And this side, so the longest side is always the hypotenuse. And this side, the side that is kind of opposite the hypotenuse, we call it the opposite side. And then this side that is kind of next to the, or below the hypotenuse, we call it the adjacent side. Okay. And so, let me just move that up a little bit. Okay, and so sine, so we know the acronym SO, which is basically, so sine of, let's say this angle, let's call it theta. So sine of theta would therefore be O, and H is always opposite over hypo. And then this is ka. So this tells me that it's A and H adjacent and hypo. So this will be adjacent over hypo. And then we have tangent, which is TOA, TOA. So we have tangent theta will give me O and A, so it's opposite over adjacent. Yep, and so we usually, in Singapore, we see it as TOA ka so. We kind of memorize it this way, TOA ka so. And this is how you kind of memorize it. Yep. So it's key to memorize this kind of triangle to be able to create this triangle quickly, and then you can kind of derive the rest. All right. So based on that, let's jump back into this question. And so we first see they ask for cosine AED. So I'm going to just kind of label that that angle. AED is this angle, and so cosine of, trying to find cosine of this angle. And one thing to note for sure, it belongs to a few triangles. One triangle it belongs to is this. The problem is we don't really know what this length is or this length is. We only know this length. So maybe it's not that useful, but another triangle it does belong to is this triangle. Can you see? Yep. And if you kind of rotate the paper a little bit, you will see that if you're looking at this triangle, where this 90 degrees, and this is the angle I'm talking about, then this will be my hypotenuse as usual, and this will be my adjacent, and this will be my opposite. Yep. And so a cosine of AED will therefore be cosine, so let's go back there again, is adjacent over hypotenuse, so that will be 5 over 13. And that's it. Yeah. And so if you're having trouble kind of visualizing, I can redraw it over here, where this is EAB, and this is the angle we're talking about, right? And this is my 90 degrees angle. Yep. And then you can slowly see that if I rotate it kind of like this way, what I get is this. Or you can just rotate the screen or the paper. And I think you should be able to see it, that this is EAB, A and B. And you can see clearly that this will be my hypotenuse. This is the adjacent side, and this is the opposite side. Yep. And of course, hypotenuse, this was 13, and adjacent, this was 5, and that's why it's 5 over 13. Yep. Now part B, tangent EBC. So let's highlight that. EBC is basically this. Okay. And okay, so now it looks a bit weird because we're like, oh, it's not even a part of any triangle, right? This angle is not even a part of any triangle. But it is next to this angle, which is a part of a triangle. And I think from here I just gotta take a little commercial break, if you would, to cover a very another very key concept. And maybe let's go here once again. Let's say now we have an angle theta over here right now. This will therefore, since it's a straight line, is 180 degrees minus theta. And one key property that is important to know and memorize is that sine of theta is equal to the sine of 180 degrees minus theta. They are the same. They're completely the same. So for example, if this was just an example, if this was 30 degrees and 180 minus 30 is 150. So I would say for example, sine of 30 will equal to sine of 150. And if you don't believe me, you can take out a calculator to try. Yeah, cosine theta is actually negative of cosine 180 minus theta. So what it means in our case here is that cosine of 30 equals to negative of cosine of 150. And once again, you can verify that with the calculator. And for tangent, it is the same. It's also a negative. Tangent. So tangent 30 equals to negative tangent 150. So that's pretty cool. It's a very useful result. So and why is it useful is because over here, it means that even though we don't know what this is, the tangent of this, we can find the tangent of this, and then this will just be the negative of that. Right? And so let me demonstrate for part B. Tangent of EBC. So let's first find tangent of EBA, right? Which is this angle, EBA. And the tangent of this angle is basically okay, right now this is no longer adjacent, hypo and opposite, right? Because now we're looking at a different angle. I'm just going to erase this. Okay. And when we're looking at this angle now, EBA, then this is now my opposite, and this is now my adjacent. Of course, this is still my hypo for this triangle. And so, tangent of EBA is therefore opposite. Look up here, opposite over adjacent. And so that would be 5 over AB. The problem is I don't know what AB is. Can I find it? So let me look at the triangle once again. I know this is 13, this is 5, 90 degrees. I can find this using Pythagoras theorem. So I can say this is AB. I can say 5 square plus AB square equals to 13 square. And you will see that this solves to be 12. So AB is actually 12. Yep. That means this is 12. So tangent. So let's come back here. Now that we found AB, we can say tangent of EBA is 5 over 12. And what do we know? We know that the tangent, so this is like EBA now. Tangent of EBA is 5 over 12. So tangent of the other angle, 180 minus theta, is just the negative of it. So we can say tangent of EBC is therefore negative 5 over 12. There we go. Finally, they're asking for the length AD. So let's look at this length AD. And to do that, really, I think it's worthwhile to look at this triangle, right? This triangle. So I'm just going to draw it down below. Maybe let me just do it aside. Part C. So yeah, let's draw this triangle. There, this is A and this is D. And since this is 90 degrees, so this must be 90 degrees as well. So that's useful because it tells me this is a right angle triangle. Okay, 13 is this whole length, not this length. So I don't actually know what this length is. And I know this is 12. And I don't really know much else, but I do know that tangent of this angle, which is a DBA, right, is actually, which is the same as EBA, is actually 5 over 12. Yeah, right, we got it from here. EBA, tangent of EBA, this angle, is 5 over 12. And this angle is basically this angle, 5 over 12. And the tangent of it is 5 over 12. And so what we can do is we can try to find angle DBA, which is simply tangent inverse of 5 over 12. And I'm just going to leave it like this, because I don't want to round up or round down. I can just say I can find that angle. And then now I'm trying to find AD. I can say that for this angle, I can note that this is my hypotenuse, right? If this is the angle and this is my right angle, and this would therefore be my opposite, and this would be my adjacent. And really, to really see it, I have to rotate the entire triangle upside down. So you can kind of turn your head and look, and you will see that, yeah, what I mean. And so I can say that if I'm trying to find AD, so I'm trying to find the opposite side. So let me use, and I know the hypotenuse. I'm trying to find opposite. I know hypotenuse. Which function gives me opposite and hypotenuse? Sine, right? So what I'm going to do now, I'm going to say sine of angle DBA is therefore opposite, which is AD, over hypotenuse, which is 12, right? And do I know what DBA is? Yes, DBA is simply tangent inverse of 5 over 12, right? And so don't get frightened. Just key this in first, tangent inverse 5 over 12, and then immediately sign that, whatever you get, so that you don't round up or round down. Yeah, that's the only reason why I'm doing this. And then once you find it, what you can do, you will immediately see that you get 5 over 13 here. And then you basically just cross multiply, and what you get is you get AD equals to 60 over 13. Yep, and there we have it. So if you're not very sure about how to cross multiply, I'll just do quickly. So you just kind of do this. So we can say that 5 times 12 equals to 13 times AD. Right, and so AD, therefore you multiply by 13, but you want to get rid of the 13, so you just divide both sides. Yeah, and that gives me 60 over 13. All right.